Well, hey there, welcome to the first section of this course, Chapter 1, Introduction to Statistics. Before we get started with this lesson, it's important to establish goals. Each chapter builds upon itself in this course. For example, what we learn in this chapter will be used and expanded on in later chapters. This makes it all the more important to ensure that the content in each chapter is understood. By the end of the lesson, you should be able to understand the following: why we use statistics, the relevance of statistics, important statistical terms, the various scales of measurement and their relevance, or in other words, why we need various scales of measurement, common symbols used in statistics, and being a statistics course, mastery of the basic algebraic concepts will be needed. In this chapter, we will review the order of operations. Finally, it's important that you are able to differentiate between relationships and experiments. You know, there are multiple purposes throughout the social and natural sciences for statistics. It is a vital component in scientific testing. Statistics are used to describe, predict, and explain scientific phenomena. Statistics are used by psychologists, anthropologists, sociologists alike to explore and describe behavior, thoughts, and feelings found in humans. It can also be used to predict the likeliness of an event occurring. For example, statistics are used by meteorologists to predict weather patterns and cloud formations. It can also be used to explain why certain behaviors occur. So just as statistics is used to determine patterns of behavior in the present and future, it can help us understand prior behaviors and reactions to certain stimuli as well. Statistics are everywhere. In fact, our world would look very different, primitive even, without the use of statistics. It's used to explain, describe, and predict election results. Statistics is used in public sector and private sector to determine what tactics work to increase the consumption of goods and services. Social networking platforms such as Instagram, Twitter, and Facebook are constantly using statistics to increase users and maximize profits. One of its more well-known obvious uses are for sports predictions and gambling. Individual player and team stats can be calculated to not only determine the likely winner of a game, but a projected score for each team as well. And then gamblers are constantly using statistical methods to decide when to raise, fold, or call. The casinos themselves use statistics to monitor how much revenue they are likely to take in. Now here's the part where we cover some important terms. The first terms that we are going to cover are the case or subject, the sample and its relation to statistics, population and its relation to the parameter, and finally, the variable. It's important to clearly understand these terms because we will be using them for the remainder of the semester. I strongly suggest writing these terms down on flashcards and practicing them. First off, we're going to cover the case, which is also known as the subject. Although these terms can be used interchangeably, the subject is more likely used to describe a single person. Regardless, the case or subject is one single unit used in a study. For example, let's say we have an experiment that is looking for a cure for cancer. This experiment uses 100 cancer patients as participants in the study, and each individual participant would represent a single case or subject. Next is the sample. This is the group of subjects in a study that are part of a larger group. In reference to our previous example investigating a cure for cancer, our sample would be all 100 participants that are in the experiment. The word statistics is synonymous with the sample. When we talk about statistics, we are referring to the number that summarizes the sample. Next, we have the population. Our population is the group in its entirety that a sample is drawn from. So in our example, the sample would be our participants who have cancer, and our population would be everyone in the world who has cancer. We select the sample directly from our population. Just as a statistic is synonymous to the sample, the parameter is related to our population. The parameter is the number that summarizes a population. Lastly, we have our variable. The variable tends to be the factors that we are measuring or the factors that we are investigating. The variable is a measurement that can vary from person to person or subject to subject in a sample. An example would be height or weight. These variables differ from person to person, case to case. Now, when research and experiments are conducted, it's not very common that we are able to test an entire population. There are often too many subjects or cases to realistically pull from. For this reason, we sample a more manageable number from our population. For example, if we want to sample Chinese Americans to see who they are likely to vote for in the next presidential election, it would be nearly impossible to sample every single Chinese American throughout the United States. So, for this reason, we want to choose a representative sample of the population to test or survey. So based on this sample, we can make an inference and predict what the entire population may look like. In order to have a non-biased representative sample of our population, we make sure to use random sampling techniques. For example, we would not just survey Chinese Americans on the east coast of the United States because this may produce biased results, but rather we would want to choose our subjects at random from all across the country to avoid this regional bias. So on this slide, I will introduce scales of measurement. Don't worry if you don't fully comprehend each of the individual scales of measurement directly after this slide. I will go into greater detail by defining and providing examples for each scale of measurement in subsequent slides. Scales of measurement are one of the key factors behind this chapter. Just as we assign numbers to represent variables such as height, the general idea behind measurements are to assign numbers to the observations of the same variables. When we look at scales of measurement, we are referring to a specific numeric scale that indicates the meaning and value of the actual assigned variable. There are four different types of scales of measurement. They are the nominal scale, the ordinal scale, the interval scale, and finally the ratio scale. The nominal scale simply categorizes or provides a name for items. The ordinal scale takes it one step further by not only categorizing an item, but the category is presented in a rank order format. For example, there is a clear first, second, third, and so on choice. Building upon this, the interval scale has equal intervals between items, but does not have an absolute zero. And then lastly, we have our ratio scale. There's a strong argument that this is the most complex scale of measurement because items are categorized like the nominal scale, they're rank ordered like the ordinal scale, they have equal intervals like the interval scale, and it has a meaningful zero. This means that there can be nothing or zero of our item or variable. So the following pictures are examples of nominal scaled items. You can think of nominal items basically like a label. Numbers are assigned to represent different instances of items or variables. Now, it's important to note that these nominal scaled items cannot be placed in a rank order system. Notice that there is no first, second, or third social security number, assigned jersey number, area code, or roadway. So going to roadways, we see 64 east and 64 west. We have these numbers being applied to different instances of a variable, roadways, and east and west is used to differentiate one roadway from the other. We cannot do anything mathematically with 64 west or 64 east. Same rules apply in terms of jersey numbers on Russell Westbrook and Kevin Durant. 35 is meant to distinguish the small forward from the point guard. When we look at zip codes, certain zip codes represent certain regions. These numbers are being applied to an instance of a variable, in this particular case, region, and the zip code is just meant to differentiate one region from the other. Same thing with social security number, and if you would like to share yours with me so that I can use it for tax return purposes, I would appreciate it. You can email me at asfranklin@nsu.edu. It's like I'm just kidding. But social security numbers are unique to us. They differentiate us from other people that were born in our region. And then finally, the 7 digits to reach you. The 7 digits that were given to you differentiate you from everybody else in the world. So I am sure that once upon a time, some guy, some girl was trying to get those 7 digits because out of all of the numbers in the world, there was a certain combination that led to you. And depending on how you were feeling that day, you gave them the number or you didn't. Nominal scaled items just meant to differentiate one instance of a variable from the others. The following are examples of ordinal scaled items. With ordinal scaled items, the number assigned can be ranked. For example, you can rank school performance based on grade point average. This is how we determine valedictorian and salutatorian for a graduating class. Although numbers assigned to members of sports teams cannot be ranked, certainly their performance can. So based on the number of annual yards gained by a running back or pass completion by a percentage in regard to a quarterback, or sacks by a defensive lineman, or baskets scored by an NBA point guard, we can assign a rank to players. Another example of an ordinal scaled item in data collection would be to express the degree to which someone may agree with a statement. For example, if a question states, "How strongly do you agree with this statement I'm getting ready to say?" This is the most exciting audio video lecture you've ever heard. A rank can be assigned to each number. I hope that you would say strongly agree. I'm trying, folks. Remember, interval scaled items not only categorize and rank order items, but they also have equal intervals. However, it does not have an absolute zero. An absolute zero is when a measurement of zero can be linked to an instance of a variable, and the presence of that zero means that there is an absence of the variable. For example, in terms of our interval scaled items, we have temperature, personality assessment values, and SAT scores. Now, each of these variables, folks, has equal intervals. For example, when we look at temperature, there are even degrees for each one, and there are an even set of points between SAT scores and personality scores. Keep in mind that these examples do not have an absolute zero. In other words, if we were to hit zero in temperature, it doesn't mean there's an absence of temperature. Let's dig into it a little bit more in depth with our example of personality. For example, if a personality scale looks at a score of conscientiousness, and conscientiousness deals with our trait of being careful or vigilant, there is no such thing as having the complete absence of conscientiousness. And it's worth saying again, so I'm just going to say it. Same as temperature, although we can have 0 degrees on a thermostat, 0 degrees does not mean we have the absence of temperature. So I'm sure that all of my students from up north can certainly vouch for it. You can go below 0 and it can be really cold, and when you hit 0, it doesn't mean that you walk outside and you feel nothing. Lastly, we have ratio scale items. Unlike interval scaled items, ratio scaled items have an absolute zero. In other words, when we get to zero on the measurement of that variable, it means that that variable does not exist. For example, 0 pounds truly is the absence of weight. Money and time are other examples of ratio scaled items. For example, there is no such thing as having, there is a such thing as having no money or no time. And the number of pictures left on a Polaroid camera and height are additional examples of ratio scaled variables. They start from zero. That zero means there's an absence of the variable, and then there's an increase that takes place as one goes above the measurement of zero. So next, I want to cover the difference between discrete and continuous variables. While discrete variables are categorical and consist of whole numbers, continuous variables cannot be placed into distinct categories and fall anywhere on the scale. So continuous variables are not whole numbers. They can be broken into decimals and are typically defined by real limits. These real limits are defined by plus or minus half of an observed high score. Now, going back to our scales of measurement, looking at these examples, I want you to take out a piece of scratch paper and determine the type of measurement scale. Is it nominal, the scale that simply categorizes items like a jersey? Is it ordinal, the scale that categorizes and rank orders items like the ranking of the top paid actors? Is it on the interval scale, the scale that categorizes and rank orders items and has equal intervals but does not have an absolute zero? Or is it on the ratio scale, the scale that categorizes and rank orders items has equal intervals and a zero? That means the absence or none of the thing being measured. Next, I would like you to determine if each one is discrete or continuous. Can it be placed into set categories and only consist of whole numbers? Or is it on a sliding scale that can be broken down into decimals? So at this point, I want you to complete this table on your piece of scratch paper, and you can go ahead and pause this video because I'm getting ready to provide the answers. All right, so let's take some time and talk about the answers to these 6 items I had you complete. So nationality. Nationality speaks to where a person may be from in the world, whether or not they are American, Chinese, Australian, European, etc. If we were to take numbers and apply it to these different instances of the variable nationality, okay, we would simply take random numbers. Don't even have to start with one. We could go 5 is American, 6 is Chinese, 7 is Australian, etc. Using those numbers to differentiate these different nationalities would just serve a nominal or label purpose. These numbers would simply be meant to differentiate one person's regional origin from another person's regional origin. If we went that route and going 5 is American, 6 is etc., whatever, ultimately these variables would likely be discrete because we're not going to take the time in making American 1.5 and Chinese 1.6. That would just be too cumbersome. It would defeat the purpose of statistics. Statistics is supposed to organize, summarize, and help us to easily interpret information. So individuals with nominal scaled items, if they assign numbers to them, they usually go with whole numbers. Whole numbers are just meant to differentiate one instance of the variable from the other. Moving forward with hand pressure. Hand pressure. If an individual was to go see a physician or a psychometrist of some sort and take a hand pressure test, when they use their digits in their palm to exert force on whatever apparatus the physician or psychometrist has them use, their hand pressure is going to start off at zero, and that zero is going to mean an absence of pressure. Right, and then from there, the number can increase and likely fall in between whole numbers, making it continuous, and thus we'll have a variable that is indeed ratio. Now, once the individual finishes with the hand pressure test and they release the apparatus from their grasp, you're going to see that the pressure drops down to 0. And again, that 0 represents an absence of pressure. So the 0 in ratio variables means an absence of the variable. Baseball team rank. I don't even know why I listed this here because I don't watch baseball. So I'm just going to make up a whole bunch of teams to emphasize my point here. So baseball team rank. A lot of times when you are tasked with identifying a scale of measurement for a variable, if it says rank in it, then that's a surefire way for you to know that it is an ordinal variable. So let's say a fan was tasked with, here comes the fabrication, folks. So let's say a fan was tasked with rank ordering their favorite baseball teams. I only know one. Let's go with the Baltimore Orioles, throw them in there. And I'm just going to bring a bunch of football teams in here. So the Cardinals and the Rams. All right, so let's pretend like they're baseball teams. Humor me, folks. Right. So let's say they said that the Baltimore Orioles were number one because everything that Charm City does is fabulous, right? So Baltimore City is number one, and then let's say the Cardinals are number two, and then finally number three is the Rams. Now, it's an ordinal scaled variable. If we apply numbers to these teams, it's just meant to rank them based on preference, based on favorite. And it's definitely a discrete variable because we're going with first, second, third, fourth, fifth, etc. That's what a rank is. Now, it doesn't have equal intervals, although on the surface it may appear to have equal intervals. So let's say a person was rank ordering the teams based on the wins that the team accrued over the season. So let's say that Baltimore Orioles had 50 wins on the season. Let's say the Cardinals had 15 wins on the season. And let's say the Rams had no wins on the season. All right, so we got a 35 gap between, in terms of wins, between Baltimore Orioles and the Cardinals. Okay, that's a 35 win gap. And then between second and third place, we got a 15 win gap. So that is not equal interval, and thus it couldn't be an interval variable. It would have to be an ordinal variable. Our rankings rank orders those instances of the variable, and it also, in doing so, categorizes them. Let's move forward and talk about letter grade on a test. This may have stumped a lot of people. You may have thought that this was a ratio variable, but the key word here, folks, was letter grade. So A, B, C, D, F. Okay, if you had to rank those letter grades, you would end up with 8 ordinal variable. Now we know that there is a great deal of variation that can occur in terms of what constitutes an A, what constitutes a B, what constitutes a C, right? And based on the individuals or the case subjects in the sample, you're definitely not going to be talking about equal intervals, right? So because we're not privy to what percentage is represented by the A, B, C, D, or F, and we're just given letter grade on a test, then it's safe to say that we need to be conservative and go with the ordinal type of measurement scale for our answer. And then anytime you're dealing with ordinal rankings in terms of scale of measurement, you should know that you need to go with discrete. Finally, pregnancy tests. Somewhere around the world, a woman is crouched over in the bathroom, urinating on a stick, and she's hoping for good news, or maybe she's hoping that she doesn't have any news to share. Usually when you take a pregnancy test, you usually see a plus or a minus, right? The plus means hooray, child is on the way, right? The minus means no, try again. You gotta wait till you ovulate, that type of thing, right? So if we were to take numbers and apply it to the plus, minus, right? 1 would be, yeah, you're pregnant. 2 would be, nope, it's not registering yet, right? It's not showing up yet. So that would simply be a nominal measurement scale, and it would definitely be discrete. Finally, with the checkbook balance, okay, put interval / ratio here. Really and truly, it's a ratio variable, but I put interval in there because, yeah, if you got zero in your Bank of America, BB&T, Wells Fargo statement, if you got a zero, yes, it means that you are indeed broke, or uh, let's be theologically correct, in between blessings. But there is the possibility of you dropping below that zero, right? And can kind of getting a -1, -2, -3, etc. There's definitely equal intervals when we talk about cash flow in terms of pennies, dollars, etc. Right? So that is why I put interval slash ratio. And then, of course, it's continuous because you can have $1.25 in your pocket. I have been there. And ultimately that money that you could earn could fall anywhere between those whole dollar amounts. So there may be instances where you're completing examples in this class and you can make the case for interval or ratio. uh, I think that it would be best for you to provide an answer, of course, and then provide your justification so that my TA and I can give you feedback on your rationale. This slide may be a review from your algebra class, but it's important to cover. Being a stats course, we will be doing problems that require the knowledge of solving algebraic equations. The order of operations will remind us the exact order of steps to complete when we work through problems. You can remember the order of operations by using the acronym PEMDAS. A little mnemonic or a trick to remember this acronym is please excuse my dear Aunt Summer Walker. Just tag on Walker to the S. The first step is the P or parenthesis. When looking at an equation, you will start by conducting the math that is found within parentheses first. The second step to any equation is calculating the exponents. After both the parentheses and exponents are complete, we will move from left to right calculating any multiplication or division within the equation. The final step is to complete any addition and subtraction found within the calculation. Similar to multiplication and division found within the equation, we will be working from left to right on the addition and subtraction parts of the problem as well. Next, I want to discuss the two main research approaches. The first one is the correlational method. The correlational method involves two different variables observed to determine whether there is a relationship between them for each individual. The key word in this definition is relationship. When we examine correlations, we are determining if there is a relationship between the two variables. Examples of correlational studies would be examining the relationship between job satisfaction and years of employment, or the relationship between number of jobs and amount of income. When we examine correlations between variables, there are three possibilities that may happen. Number one, there is no correlation or relationship found between the two variables. Number two, there is a positive correlation. And number three, there is a negative correlation. A positive correlation happens when both variables move in the same direction. If one variable increases, the other variable increases. For example, as a student's study time increases, so does his test average. Now, a positive correlation would also be if one variable decreases, the other variable decreases as well. For example, when enrollment at college decreases, the number of teachers decrease. A negative correlation demonstrates a relationship between two variables as well, but while one variable increases, the other decreases. For example, the more books I buy for class, the less money I have in my bank account. As the number of books I have increases, the value on my bank statement decreases. This is a negative correlation. Now, it's vital to remember that correlation does not prove causation. For example, studies have shown that when ice cream sales go up, so does the crime rate. Now, just because there is a correlation does not mean that one causes the other. Does it make sense that ice cream sales cause more crime in an area? Probably not. Sometimes there is a third factor that can help to explain a correlation. For this example, high increases in temperature can cause people to become irritated and crime to break out in certain areas. It can also cause children to want to buy more ice cream to cool down. We can never state that correlation proves the cause. We can only make inferences. Now, the second research approach involves the usage of experiments. And in talking about experiments, first I want to talk about operational definitions. The operational definition is the definition of a variable of interest that allows it to be directly measured. First, the operational definition describes a set of operations for measuring a construct, and secondly, it defines the construct in terms of resulting measurements. For example, if we were interested in testing if violent television leads to aggressive play, we need to first find out how to measure the level of aggressive play, maybe through behavioral charts. Then we need to define aggressive play based on the measurements or behaviors found. We do this by conducting an experiment. An experiment is a deliberate manipulation of a variable to see whether corresponding changes in behavior result in another variable. This allows for the determination of cause and effect relationships. Experiments usually involves comparisons of two groups. A researcher must exercise control over the research situation to ensure that other extraneous variables do not influence the relationship. For example, if we are investigating if violent television increases the risk of aggressive play, we need to control for all other variables that could influence aggressive play. So each participant in the sample in each condition needs to have the same amount and type of television exposure and should be controlled for other factors such as diet, extracurricular activities, and many other personal and environmental variables. In the experiment, we have two essential components. These components are the independent variable, also known as the IV, and the dependent variable, also known as the DV. The IV is the variable that is manipulated by the experimenter. For example, if we were to look at a study that is investigating if violent television and movies leads to aggressive play in children, the IV would be the violent television. The DV is what we are actually measuring or assessing for change as a result of manipulating the independent variable. So in this example, we are interested in looking at the level of aggressive play in children and observing if it changes. So aggressive play would be the dependent variable. The dependent variable is the variable in an experiment that represents the measurable response or behavior of the subjects in the experiment. In an experiment, we have two groups, the experimental group and the control group. In our previous example, examining the effects of violent television on aggressive play, the experimental group will be the group that will watch television, and the control group will not watch any television. The researcher is manipulating television by having some individuals watch violent cinema and others not watch anything. That's why television would serve as the independent variable. The experimental group are the subjects in an experiment who are subjected to the independent variable, and the control group contains the subjects in an experiment who are not subjected to the independent variable and who may receive a placebo treatment. Now, a placebo treatment essentially controls for confounding or extraneous variables. The control group is used as a standard to compare the effects of the condition the experimental group is exposed to. Now let's talk a little bit about extraneous variables. Extraneous variables are variables that can affect the internal validity of a study by providing an alternative explanation to an effect. When conducting a study, it's important to control these variables to ensure that the results are based on the factor we are manipulating and nothing else. There are two primary types of extraneous variables. Environmental variables are outside factors like light, time of day, and weather conditions. Participant variables are internal factors or characteristics such as age, gender, and intelligence. These factors can all affect the outcome of an experiment. That is where random sampling comes in to offshoot that. It helps by eliminating some of the extraneous variables by ensuring participants are not selected based on any specific extraneous or confounding variable. Another research method that I want to briefly discuss as I wrap up this lecture are non-experimental studies. In non-experimental studies, there is not a true independent variable. The independent variable that is used to create different groups in non-experimental studies is often called the quasi-independent variable. So oftentimes these are independent variables that cannot be manipulated for ethical reasons. So some IVs of this nature may include things like sex, sexual orientation, and even a history of child abuse or history of domestic violence. A researcher could not manipulate that across groups. Oftentimes, what you will see throughout this course is the usage of the IV being used to create groups of scores on certain variables.